Combustion and flame. Different kinds of fuels for various purposes are used at home, in industry, and for running automobiles. These fuels are cow dung, wood, coal, charcoal, petrol, diesel, compressed natural gas, CNG, etc. All these fuels produce carbon dioxide upon burning. When a fuel burns, it gives out heat and light. The candle burns with a flame, whereas coal does not. Coal always burns without flame, but becomes red hot and gives out heat and light both. A thin wooden stick burns easily, whereas a thick log of wood does not catch fire easily. Some substances burn with a different color of light. For example, magnesium ribbon burns with bright white light, while LPG burns with a blue flame. Combustion. Combustion is the process of burning of a substance in the presence of oxygen. When any combustible substance burns, it produces heat and light. For example, when charcoal burns in air, it gives out carbon dioxide and heat. Similarly, natural gas or methane burns in air and forms carbon dioxide, water vapor, and heat. When magnesium ribbon burns in air, it gives off a bright white light in the form of white glow and produces a white powder of magnesium oxide. Combustion can occur only when certain conditions are available. Conditions necessary for combustion. Combustion occurs when all the necessary conditions are available for the reaction. The three most important conditions necessary for combustion are presence of combustible substance. The combustible substances need availability of oxygen as well as the right amount of heat in order to combust. The substances which undergo combustion are called combustible substances. For example, LPG, kerosene, petrol, etc. The substances which do not burn in air and oxygen are called non-combustible substances. For example, iron, glass, water, etc. For example, water, sand, iron, nails, stones, glass, etc. do not catch fire on heating in air. Such substances are called non-combustible substances. Water and sand are used to extinguish fire. White paper, kerosene and cloth can be burnt by slow heating. Wood requires strong heating for burning. A thin sheet of paper can be burnt easily, whereas a thick cardboard sheet requires strong and prolonged heating for burning. Presence of supporter of combustion. The supporter of combustion, that is, oxygen, must be present in sufficient quantity for combustion to take place. Ignition or kindling temperature. Temperature is an important condition for combustion to occur. The lowest temperature at which a substance catches fire is called its ignition temperature. Kerosene is a fuel that has a low ignition temperature. The substance with low ignition temperature is highly inflammable and catches fire very quickly. For example, petrol, LPG, ether, and alcohol. Actually, different substances burn at different temperatures. Fire control. Fire can be easily stopped by stopping the supply of either air or heat. Water is not a good extinguisher for electrical fires. If electrical wiring is on fire, pouring water on it will conduct the electricity through water. It may cause the person to get electrocuted. As water is heavier than petrol, it is not useful for extinguishing oil or petrol fires. It is best to use carbon dioxide as an extinguisher. Carbon dioxide is heavier than oxygen, so it covers the flame like a blanket, cutting off contact between the fuel and oxygen. Powder of sodium or potassium bicarbonate can also be used to get carbon dioxide. The first automatic fire extinguisher was patented in England by a chemist called French C. Hopfer. The modern fire extinguisher was invented by British Captain George William Manby. Classes of fire. Fire can be classified into 5 classes on the basis of the substances involved in the burning process. Class A, ordinary combustible. Example, trash, wood, paper, cloth. Class B, flammable liquids. Example, oils, grease, tar, gasoline. Class C, flammable gases. Example, hydrogen, butane, methane and ethylene. Class D, combustible metals. Example, magnesium, titanium. Class E, electrical equipment. Fire extinguishers. Depending upon the class of fire, we use different fire extinguishers. Class A, water, chemical foam, dry chemical. Class B, carbon dioxide, dry chemical. Class C, carbon dioxide, dry chemical, halon. Class D, dry powder, suitable for specific combustible metal involved. Fire may be controlled by removing one or more of these conditions. Since it is not possible to remove all the combustible substances from the place of fire, fire extinguishers are based on the principle of either bringing down the temperature below ignition temperature or cutting the supply of oxygen, or both together. Various types of fire extinguishers are used to put off fire depending upon the nature of fire. Water as fire extinguisher. You must have seen fire brigades spraying water under pressure to extinguish fire. It is the most common fire extinguisher which cools the most combustible substances below its ignition temperature. The water vapor also surrounds the combustible material and cuts off the supply of air. Water works well when the fire is caused by combustion of paper or wood. It cannot be used to extinguish fire caused by burning of oil, petroleum, etc. Because being heavier than them, it sinks down and the oil keeps burning on top. Water should also not be used to put off fire in electrical equipment and wirings, as water conducts electricity and may cause electrocution to those involved. Use of blanket. If fire is at a small scale, then a blanket can be very useful in controlling the fire. When the burning object is covered with blanket, it helps in cutting off oxygen supply. This helps in putting off fire. Carbon dioxide is fire extinguisher. For fires caused by burning of inflammable liquids like petrol or oil, carbon dioxide is the best fire extinguisher. Carbon dioxide, being heavier than oxygen, covers the combustible substance like a blanket. As the contact between the fuel and oxygen is cut off, the fire is controlled. It is also used to control fire caused by short-circuiting, as it does not harm the electrical equipment and does not conduct electricity. Carbon dioxide is stored in liquid form at high pressure in cylinders. When released at the site of fire, it comes out in vapor form, expands enormously in volume and cools down. Therefore, it not only cuts off the oxygen supply around the fire, but also brings down the temperature. Some other sources of carbon dioxide are sodium bicarbonate or potassium bicarbonate, which on heating give off carbon dioxide. When dry and powdered form of these chemicals are released in good amount near the fire, they heat up and release carbon dioxide, thereby extinguishing the fire. Types of combustion. The type of combustion differs depending on the type of fuel. Based on nature and intensity of fuel, the combustions are classified into 3 types. They are rapid combustion, spontaneous combustion, and explosion. Rapid combustion. The combustion in which large amount of heat produced within a very short time is called rapid combustion. For example, liquefied petroleum gas or LPG burns very quickly, producing a lot of heat. When a burning matchstick or a gas lighter is brought near a gas stove and its knob is turned on, the gas immediately starts burning, with the evolution of heat and light are produced during the reaction. It is known as rapid combustion. Spontaneous combustion. When a substance suddenly bursts into flames without any extra heating or any apparent cause, it is called spontaneous combustion. For example, coal dust results into many disastrous fires in coal mines. Forest fires are also spontaneous and are caused due to the sun's heat or sometimes due to lightning. White phosphorus also burns in air spontaneously as its ignition temperature is only 35 degrees Celsius. Explosion. The combustion which is accompanied by the release of light, sound and large amount of heat is called explosion. For example, the burning of crackers produces a large amount of heat, light and sound because of chemical reaction. Flame. Flame is the visible and gaseous part of fire. When vapor of a substance undergoes combustion, it results in flame. Only those substances which vaporize on burning produce flame. If a substance does not get vaporized, it does not produce flame. The substances which vaporize during burning give flames. For example, kerosene oil and molten wax rise to the wick and are vaporized during burning and form flames. Charcoal, on the other hand, does not vaporize and so does not produce flame. Structure of flame. There are three zones in a flame, that is, outer zone, middle zone and inner zone. Outer zone. This zone is blue in color. It is the hottest part of the flame because complete combustion takes place in this part. Middle zone. This zone is yellow and orange in color. It is moderately hot because partial combustion takes place here. Inner zone. This zone is dark in color. This is the coolest part of the flame because no combustion takes place in this part. Luminous flame and non-luminous flame. A luminous flame is yellow in color and is formed by incomplete combustion of fuel in insufficient oxygen availability. Its temperature is lower than the non-luminous flame. It produces heat and light and leaves black carbon particles and other residues. A non-luminous flame is blue in color and is formed as a result of complete combustion of hydrocarbons in excess of oxygen. This type of flame does not leave any residue, produces heat but has very little light. Fuel. Fuel is a substance that burns to produce heat and light energy. Some commonly used fuels are wood, coal, kerosene, petrol, diesel, LPG and CNG. The fuels are used for cooking in automobiles and to generate electricity. On the basis of their physical state, fuels have been divided into three categories. Solid fuels. The fuels that exist as solids at room temperature are called solid fuels. For example, wood, charcoal, coal, coke, cow dung cake, etc. Liquid fuels. The fuels that exist in liquid state at room temperature are called liquid fuels. For example, petrol, diesel, kerosene, etc. Gaseous fuels. The fuels which exist in gaseous state under normal conditions are called gaseous fuels. For example, CNG, LPG, etc. Calorific value of a fuel. All combustible substances cannot be used as fuels, and all fuels cannot be used for all applications. Actually, different fuels produce different amount of heat and light energy on burning. Besides the energy produced, the choice of a fuel for a particular use depends on its availability, efficiency, cost, and the amount of pollution caused by it. The amount of heat energy released by a unit quantity of fuel on complete combustion in oxygen is called the calorific value of the fuel. The calorific value is expressed in kilojoules per kilogram, kilocalorie per kilogram, etc. Higher the calorific value of a fuel, the better is the fuel. Hydrogen is considered the best fuel as it is the highest calorific value. However, it is difficult to handle it in gas form. liquid hydrogen is used as a fuel in spacecraft. The calorific value of some of the fuels, biogas. The calorific value is 35 to 40 kilojoules per kilogram. Coke, calorific value is 28 to 31 kilojoules per kilogram. Coal, calorific value is 15 to 27 kilojoules per kilogram. Charcoal, calorific value is 29.6 kilojoules per kilogram. Hydrogen, calorific value is 141.9 kilojoules per kilogram. Kerosene, calorific value is 47 kilojoules per kilogram. LPG, calorific value is 48 kilojoules per kilogram. Methane, calorific value is 55 kilojoules per kilogram. Petrol, calorific value is 48 kilojoules per kilogram. Each kilogram of LPG produces much more heat than 1 kilogram of wood or coal. The calorific value of LPG is the highest among wood, charcoal and LPG. In rural areas, cow dung and wood are still used as fuel because these are very cheap and easily available. Characteristics of a good fuel. There is probably no fuel that could be considered as an ideal fuel. We should look for a fuel which fulfills most of the requirements for a particular use. Fuels differ in their cost. Some fuels are cheaper than others. However, a good fuel has some unique characteristics. It is readily available. It is cheap. It burns easily in air. It burns at a moderate rate. It produces a large amount of heat. It does not leave behind any undesirable substance. There is probably no fuel which can be considered as ideal fuel. Fuel efficiency. Calorific value gives the measure of fuel efficiency. The amount of heat energy produced on combustion of 1 kg of a fuel is called calorific value of that fuel. It is expressed as kilojoule per kilogram. Harmful effects of burning of fuel. The gaseous products such as carbon dioxide or carbon monoxide and particulate matter, ash, soot, etc., produced by the burning of fuels affect the environment in many ways. On burning, wood releases unburnt carbon particles in the environment. These fine particles cause respiratory problems such as asthma. Moreover, wood is procured from the trees, excessive cutting of which leads to deforestation and various environmental hazards. If oxygen supply is insufficient, coal and burning forms carbon monoxide, which is a poisonous gas and can suffocate and kill people exposed to it. Incomplete combustion of liquid fuels like petrol, kerosene and diesel produces poisonous gases and soot. Carbon dioxide is a greenhouse gas and is responsible for global warming, that is, rise in the average surface temperature of the atmosphere of the Earth. This in turn leads to many problems like melting of glaciers and rise in the sea level, causing floods in the coastal areas. Fuels like coal and diesel have sulfur as impurity, which upon combustion forms sulfur dioxide, a very poisonous and corrosive gas. Petrol engines upon incomplete combustion of petrol from oxides of nitrogen and carbon which pollute the atmosphere. These oxides of nitrogen and sulfur dissolve in rainwater and form acid rain. Such rain is very harmful to crops, soils, buildings, etc. Nowadays, CNG, compressed natural gas, has proved to be a better fuel than any of the solid or liquid fuels mentioned earlier. CNG burns completely without leaving any residue. They have a high calorific value and low ignition temperature.